Okay. All right, so we're going to do the Pascal triangle. And you're going to see that this will help you to find binomial expansion of higher power. We already know, okay, we already know how to do this. So we're going to say intro. Okay, so we already know how to expand things like a plus b square. Okay, so we know how to do that. If I ask you to do a plus b cube, you can also do that. It won't take that long. Even if I ask you to find the answer for a plus b to the power of 4, still you can do that. But then if I ask you to do things like, let's say, a plus b to the power of, even if I say 8, then becomes, a little bit too long. All right? Okay, so let's do the first one, because that is something that we know already. And you know that this is equal to a squared plus 2ab plus b squared. All right? And then if you want to do the next one, well, the next one, can you see that a plus b cubed is the same as if you do a plus b squared multiplied by a plus b? Okay, do you understand that? And we already have the answer for a plus b squared, so we're going to write it down in here. And then we're going to multiply that by another a plus b, another factor. So let's do that. So we're going to have a squared plus 2ab plus b squared. Okay, so that is the answer for my ab squared. And then we're going to multiply this by another factor, which is a plus b. All right? Okay. And if you multiply this factor by this one, then you're going to have 1, 2, 3, 2. So you're going to have 6 terms. Okay, because you're going to multiply 2 terms by 3, so altogether you're going to have 6. Okay, let's do that. All right, so if you multiply a by a squared, so it's going to be a cubed. All right? And then we're going to multiply a by 2ab, so that will give you 2a squared b. And then if you multiply a by b squared, that will give you ab squared, right? And then we finish with the a. Now we're going to do the b. Okay, so if you multiply a squared by b, so you're going to have plus a squared b. And then if you multiply b by 2ab, so you're going to have 2ab squared. And finally, if you multiply b by b squared, it's going to be b cubed. At this point, I really want you to pay attention to, I'm going to change color. Give me 1 sec. I want you to pay attention to this. In here, the a squared has a coefficient equal to 1. All right, so this is 1. And then we have 2. And then we have 1. Okay, so we have 1, 2, 1. All right, can you see that? Okay, if we simplify this, then see what happens. Okay, do we have any like term?
Yes.
So we have 2a squared b, and then here we have another a squared b, so altogether is 3. Okay, so it's 3a squared b. And then ab squared, we have 2 more, so we also have 3ab squared. And finally, we have b cubed. Okay? Again, pay attention to the coefficients. So we got 1, 3, 3, and 1. Can you see the symmetry? Okay, can you see that we have a symmetry in this, and also we have a symmetry in that one? And also, I want you to look at this very, very carefully. The highest power for A is 3. Well, this is coming from the fact that this is cube. And the higher power for B is also 3. Okay, so that means that we start with 3 and we finish with 3. Okay? And also, if you look carefully in here the power of A has been reduced by 1. Can you see that it went from A cubed to A squared? Can you see that? And the power of B increased, because in here, in reality, we have B to the power of 0. Okay, so it went from 0 to 1. Can you see that? Okay, and then see what happened with the power of A. So it will keep reducing. So it went from 3 to 1. And the power of B increased. So you got 0, 1, and 2. Until the power of A will disappear. So it's going to be A to the power of 0. And we finish with B cubed. Can you see sort of the pattern? Yeah. Right. Okay. All right. I want you to do, by yourself, I want you to do the A plus B to the power of 4. Can you please do that? So you're going to do it. So you already know the answer for A squared. So A plus B to the power of 4 is the same as if you do A plus B cubed multiplied by another AB. Okay, so this, I help you a little bit. So A plus B to the power of 4 is the same as if you multiply A plus B to the power of 3 multiplied by another AB. Right? A plus B. And the good thing is that you already know the answer for A plus B cubed. So all what you have to do to find the answer for this is to multiply this by another A plus B. Can you please do that? And then you're going to simplify and tell me what the answer is. Okay, so make sure that you expand it properly. Be careful with the powers. And then I want you to simplify and put the power for the A in decreasing order, I guess, and the power of B in increasing order. So if you have that, then that would be awesome. Okay, can you tell me, if I know that you finished, can you please tell me what the answer is?
I got A to the power of 4.
A to the power of 4.
Plus
Mm-hmm.
plus 6a to the power a squared b squared
Mm-hmm.
plus 4ab cubed
Yep.
plus 4 to the, b to the power of 4.
Perfect. Okay, so you can see clearly the pattern. All right, so you have 1, so we have 1, 4, 6, 4, and 1. All right?
Is it 6 there? Because it's just 3 plus 3. Like, how does the 6 fall in that?
That one?
Yeah.
I'll show you. I'll show you where this is coming from. Okay, so you can see, you can clearly see the pattern of the pronumeral. So you can do the pronumeral without the coefficient. Very, very easy. Even if I ask you to do the expansion for that one, you can easily do the pronumeral. But the hard part is to find, the coefficient, the numbers. Okay, so here we got 1, 4, 6, 4, 1. Okay, that is where, this Pascal triangle will help you. All right? We're going to say, also, very, very important, a plus b to the power of 0 is equal to just 1. And a plus b to the power of 1 is equal to just a plus b. Right? And in here we have 1, and here we got 1. Okay, so this is the very popular triangle. So I want you to put 1 in here, 1 in the middle of your page. And we're going to say that 1 is simply, the coefficient coming from here. Can you see that it's only 1? It's constant. So we're going to put here a plus b 0. And we're going to put 2. And then the next expansion, if you go from 0 and then 1, the next one will have 1 and 1. Okay, so we're going to put 1 here and 1 here. Okay, so we're going to put this the coefficient coming from a plus b to the power of 1. And for the next one, a plus b square, what do we have? We have 1, 2, and 1. Okay, so 1, we're going to put 1 here, 2 in here, and 1 in there. All right? And then you're going to start seeing the pattern. All right, for a plus b cube, so a plus b cube, what do we have? So we have 1, 3, 3, 1. Okay, so we're going to say 1, 3, 3, 1. All right? And let's do the last one that we've done. So it's a plus b to the power of 4. And we found, okay, that the coefficient 1, 4, 6, 4, 1. I'm going to put 1, 4, 6, 4, 1. Now, if you look carefully, if you look very, very carefully, and the side, okay, the the start and the end always is 1 for all of them. Okay, and also if you look carefully, you're going to see that this here is coming from adding this and this. So 1 plus 1 is equal to 2. And then this number is coming from 1 plus 2 is equal to 3, 2 plus 1 is equal to 3. Okay, and then 1 plus 3 is equal to 4, 3 plus 3 is equal to 6, and then 3 plus 1 is equal to 4. So what you reckon is going to be the coefficient for the next one? Wait. Let me. Okay, go.
1,
Yeah.
5,
Mm-hmm.
10,
Mm-hmm.
10, 5, 1.
That's it. Okay, so I mean that this triangle will give you the coefficient for any expansion. For example, if you want to do, let's say that we want to do the next one. Let's say, okay, let's do the next one. All right. What's the answer?
1 plus 5.
So it's going to be 1, and then
6,
15, and then
20,
20, 15,
5,
6, 1. All right? So if I now ask you to find the actual expansion for this, okay, so if I ask you to do the expansion for this is how we do it. So we're going to say, a plus b to the power of 6 is going to be equal. And this will give you, the expression in simple form. Okay, simplify. Okay, so here we go. So the first one is a to the power of 6, right? The next one is going to be, you tell me, 6 a to the power of 5
B.
b. That's correct. The next one is going to be 15 a 4 b square.
Oh,
All right? The next one is going to be 20. You tell me.
A cubed,
A cube.
B cubed,
Perfect. Next one.
15 A squared plus B times B to the power 4.
Next.
6 A
6.
and B to the power 5.
And the last one.
B to the power 6.
That's it. Lucky that the whole thing will fit. Okay, so you can do the expansion having, the Pascal triangle very, very quickly. Can you see that? So that means that you are not limited. You're not limited anymore to, the square, the very popular square. You can easily do, the cube. Okay, and then you can do any power you want. All right? But now there is another surprise. There is another surprise.
No, I hate surprises.
We have been talking. Now this is a really good one.
11 sheets?
This is a really good one.
Intro again.
Okay, do in your calculator do. Let me see. Okay, we're gonna redo this triangle in here,
Do we have to read it?
but we're gonna do only a few of them. We're not gonna do all of them. Okay. if you do this, so in here we're going to put the other one. So this is 1. And all right, so that is a little bit wonky, but yeah. Find the answer for this. 0, C, 0.
It's 1.
1, all right? Now, can you please find 1, C, 0?
2.
And then 1, C, 1.
Wait, what?
What?
2.
It's 1.
1. Okay, so I want you to see the relationship between this and this. Okay, and I want you to observe this number. So this is the, keep in mind that this is the A plus B 0, and this is the A plus B 1, and this is the A plus B 2, A plus B 3, and this is the A plus B 4. All right? Okay, so here we got the second power. All right, can you see that? Okay, so that's why I start with 2. 2C0. Can you do 2C0? 2C1.
2.
And then 2C2. Do it. No, don't be silly, just do it. Okay, and then you're going to have the same pattern. So you're going to have 1, 2, 1. All right, now let's do the other one. So this is the third power, so we're going to do 3C0, 3C2, and 3C3, and we have another one. Okay, so start again. So 3C0, 3C1, 3C2, and 3C3. So if you put that and you do the calculation, you're going to have that you have 1, 3, 3, 1. All right? Can you see that? So that means that we can rewrite, the triangle Pascal using these combination things. And that's why in mathematics we call this the coefficient, the binomial coefficients. Okay, from now on we're going to say that NCR in this context, okay, NCR, which is the same as NR, like this, I call the binomial coefficients. Okay, so the binomial coefficient. And the reason why, because this will give you the coefficient for any binomial expansion.
Wow.
Now, we're going to do another question, and then the whole thing will make sense, a lot more sense. All right, let's say now that the question is about writing the expansion of a plus b to the power of 7 using the binomial coefficients. So what you do is this. Because it's 7, okay, we need to do 7c0. So that's going to be the first one. And it's going to be, you tell me, a is going to be to the power of
1. Oh,
7. All right? And then the next one is going to be 7c1. And what is going to be the perimeter? A6b. And then the next one is going to be 7, still 7 because that is the binomial. 7c2. But you can see that this is increasing, okay? So the top one is constant, but the bottom one is increasing. So what is the next perimeter?
A.
So it's going to be a to the power of
5
5
b squared.
b squared, and then
A to the power of
7
7
c.
c 3. A to the power of 4. B to the power of 3.
Next,
7c4 a cubed to the power of b to the power of 4.
I'm going to continue here. Plus
7c5 a squared b to the power of 5. 7c6 a to the power, a b to the power of 5. Right, 6, that's
and then
c.
7
c. What are we up to? 7 is b to the power of 7.
That's it.
Good job, Archie.
All right.
Yay.
Finally, before you go, we're going to say this. I'm going to say in general. Okay, now you're going to say something that looks very, very impressive, but something that we're going to talk about later, but I'm just going to state it, okay? So this is the proposition. So position. This is a very, very, very important theorem. Okay, very, very important theorem. We're going to say if A, comma B are real numbers, so if A and B are real numbers, and N a natural number, so counting number plus 0, so we include 0.
What's the natural number?
0, 1, 2, 3, 4, 5, 6, 7, and so on, but not negative, no fraction, just
Also,
whole number, whole positive number. Okay. Then, now, do you have breakfast this morning?
no.
All right. Okay. Be ready because what I'm gonna write here is very, very impressive. Okay, but you're gonna get familiar with this very, very quickly. Here we go. Then a plus b to the power of n. Okay, so in here we have done, 0, 1, 2, 3, up to 7. That is the larger that we have done. But in here they say that a plus b to the power n is going to be equal to this. Now, be ready.
Hold on. Just let me, I just want to, no, you start.
Oh.
Okay, so it's going to be equal to the sum.
What's happening?
Sum. Okay, can you see in here, can you see that we're adding things? Okay, so this is simply an abbreviation for all this sum. That's all what it is. Okay, so they say that it's going to be equal to the sum from 0 to n. Okay, so in here we're doing from 0 to 7. Can you see that?